Good morning, class. So today we're looking at calculus. We are applying the rules of differentiation. You've got your test back as well. And I've sent you guys the memo, no? That other memo you asked, they are copying it at the moment. Okay. So I asked you to do exercise 6, and exercise 6 was on page 155. Okay. So I asked you to do the first column, correct? So what I'm going to do is I'm going to do each and every sum in the first column. Okay. With the help of you guys just now. Alright, let's start with number 1. First things first. Number 1 is find the derivative if y is equal to 3x squared minus 2 over x. Can I apply the derivative as it stands there? No, it must be in the form of ax to the exponent n. So what does that mean? I must take x up. Not so. So that will be y is equal to 3x squared minus 2x to the minus 1. Can I apply the derivative now? Yes. So this would be what? dy over dx is equal to 6x plus 2x minus 2. Yes.
Must the answer be the exponent must be positive?
Did I say? Yes. Okay. So I'll probably forget sometimes. Just remind me the exponent must be positive. So it's going to be 6x plus 2 over x. Because in the exam, they normally don't restrict. However, if the question is explicitly telling us to write it with positive exponents, it must be written with positive exponents. Alright, you all okay with that? Number 3. We got dx of 2x squared minus 11x plus 5 over 2x minus 1. Can I apply the derivative as it stands there? No. So what do? I need to factorize the numerator. So d of x, definitely 2x minus 1 would be a factor. The other one is x plus 5. You all agree with that? So, nope. X minus 5. You mustn't just say yes. What's wrong with you? Okay. X minus 5. So what happens? 2x minus 1 is cancelled. So it's d of x, x minus 5. You all agree with that? Now I can apply my derivative. What's the derivative of x? 1. Derivative of a constant is 0. You all okay with that? Any misunderstanding here? Any confusion? Number 5. You got d of x, the derivative with respect to x, of 5x minus 2 root x squared. Is that in the form of ax to the exponent n? No. It's not in that form. So, we must get it in that form. Okay, so I'm going to apply the binomial square rule. People, if you don't know how to apply the binomial square rule, write the sum out twice and multiply it. Okay? Alhamdulillah, I know it. Okay? So 5x squared is going to give you 25x squared. That times 2 is going to give you negative 20x root x. Last term squared will be positive 4x. So this here can be written as x to the half. X to the half times x is x to the 3 over 2. So it's 25x squared minus 20x 3 over 2 plus 4x. Is it now in the form of ax to the exponent n? Yes. So what do we have now? I can apply the derivative. When I apply the derivative, I drop the differentiation sign. So it's 25 times 2 is 50x minus 20 multiplied by 3 over 2 is going to give you 30x minus 1 is going to give you half plus 4 times 1 is 4 minus 1 is x to the 0. Okay. Any questions here? No? And number 7. Number 7. We have d of x of 6x squared minus 17x plus 12 over 3x squared minus 4x. So you go dx. If we look here, we can't apply the derivative as it stands. The x is a common factor. I'm left with 3x minus 4. Now of course 3x minus 4 here is one of the factors on top. So it's 3x times 2x is going to give you 6x minus 3. So I check for the middle term. So that's minus 8 minus 9 is minus 17, which makes it 3. Okay? How do I know it's going to be one of those so that it can cancel it? So it's going to be dx into 2x minus 3 over x. So what do I do now? Put each one over its own. So that's going to be dx. 2x over x is 2. And negative 3 over x is negative 3 over x. You bring the x up, it becomes negative 3x and the minus 1. Now I can apply my derivative. Not so. Derivative of a constant is 0. Negative 3 times negative 1, 3x minus 1 gives you minus 2. You all agree with that? But they ask you to write it with positive exponents, so that one comes in. So it will be 3 over x squared. Some like this people's worth 1, 2, 3, 4, 5 marks, or 4 marks. Okay, so know how to do these things. There's 7 marks in paper 1 from here onwards out, based on this exercise only. 7 marks. The previous exercise, a minimum of 5 marks. And if the tangent is asked, another 4 marks. Okay? So know this thing. It's not that so difficult. No? So I say at this point, most of our, not difficult sections, but sections that you need to spend time in, or the bit more complex to what we're currently doing is all behind us. Okay. Everything from here is easy marks. Okay. Number 9. D of x, the derivative of x of 2x minus 3 cubed. So is that in the form of ax to the exponent n? No. No. So you must get rid of the cube. So you must write this out. So it's going to be 2x minus 3 times 2x minus 3 squared. Not so? Now the 2x minus 3 squared is going to give us 4x squared minus 12x plus 9. Not so? Now we must multiply that. Okay. Which gives us d of x. It's going to give you 8x cubed minus 24x squared plus 18x minus 12x squared plus 36x minus 27. So that's d of x of 8x cubed. Those are like terms, which is negative 36x squared. 18 plus 36 is 54. Is that correct? Yes. That's 54x minus 27. Okay. Now is it all in the form of ax to the exponent n? Yes, and I can apply the derivative. So what did that give us? 24x squared minus 72x plus 54. Derivative of a constant? 0. Okay. You all okay with this? Let's look at number 11. Number 11 It's going to be d of x into x minus 2, 2x plus 3. As you can see here, it's not in the form of ax to the exponent n. So we multiply that out. So I got d of x of 2x squared plus 3 minus 4 is minus x minus 6. I can apply my derivative now. Not so. I drop this. So 2 times 2 is 4x to the 1 minus 1. Number 13. Y is equal to 3 over 2x minus x squared over 3. Now this one, many people make a mistake. Okay. So they always tend to ask something like this in your exam. To get it in this form, I'm going to bring the x only up. Can you see that? And this here I write next to it. So that will be y equals 3 over 2 x to the negative 1. Minus, there's a 1 in front there, so it's a third x squared. If it's on top, if it's next to the fraction, it could go then to the numerator or vice versa. Okay. But what other people do is they bring the 2 up with it in the first fraction. Okay. Now I can apply my derivative, so it's dy over dx equals negative 1 times 3 over 2 is negative 3 over 2. X minus 1 is going to give you negative 2. Negative a third times 2 is negative 2 thirds. X, if I minus 1 from there, I get 1. Which now gives me, as you can see, it's a negative exponent. I bring the denominator. It's negative 3 over 2x squared minus 2 over 3x. Or I could have put that x next to the 2 in the numerator. Okay, any issues here, people? Any problems? No. Alright, let's carry on. Yes? One of the media.
You must put the equal sign on our loss, or it's
Equal sign.
yeah.
Where? Yeah.
Like there, for example, there it says 4x minus 1, so you have to equal.
Why? Mustn't put the equal sign. There's an equal sign. There's an equal sign. There's an equal sign. Is it specifically for d of x?
I asked him, yeah,
Because here's the d of x, there's no equal sign. However, there's an equal sign. So I don't know. Would you be penalized? I don't think so. You won't be penalized. But find out why should there not be an equal sign. Then you tell us. No? You could be right. You just need to know why. Okay. But why would you ask such a question? What made you ask that question? So he didn't put the equal sign. Okay, nice. So find out. You was going Saturday, no? Find out and then you let us know. Okay, in the process we will all learn. Okay. Because everything we do it for a reason. You must be able to explain why you are doing it. Alright, number 15. Is that in the form of ax to the exponent n? No. So firstly, you must get it in that form. So y is equal to x, 3 over 2, minus x, 3 over 5. I wrote it from a radical form to exponential form. Okay, remember that the root will always be the denominator in that fraction. Can you see that, people? The root will be the denominator in that fraction. Of course, the numerator is the exponent under the root. So we can apply the derivative. So dy over dx equals 3 over 2 times 1 is 3 over 2. X minus 1, by that I get a half. Minus 1 times 3 over 5 is negative 3 over 5x. Minus 1 from that I get negative 2 over 5. You all agree with that? Then the instruction is to write it with positive exponents. Come inside.
Sir,
Yes?
you said that the root is supposed to be the denominator, but it's not on the second line.
The root in this line. Oh, it's not. It's supposed to be 2 over 3. Right, let's go again. Yes, Michael? Just stay out of the camera. Who sent you this?
Mr. Jackson.
Which textbooks is he referring to?
Oh,
The-
my.
Yeah, I can see it's for maths. But is the school buying the textbooks?
I don't know.
Just ask him. Can you let me know? No? The school buying the textbooks. Okay, sorry about that. So that's going to be x 2 over 3. I wrote 3 over 2, no? Minus x 3 over 5. So dy dx is going to be 2 over 3 x minus 1. On the exponent is going to give you negative a third. Minus 3 over 5 x minus 1 is going to give you negative 2 over 5. So that's going to give you 2 over 3 x to the third minus 3 over 5x to the 2 over 5. If you want, you can write this with instead of exponential form in the radical form, which is not needed. I'm just showing you something else. Can be written as 2, 3, the cube root of x minus 3 over 5 and the fifth root of x squared. This is another way of writing the same. Okay. Any issues here? No? Sorry again about that. Let's carry on with our lives. Number 17. So xy equals the square root of 3 minus 4x cubed plus 1 over x. Now, they want dy dx. But what is different here? What is different here, people? What is different here? There's a xy as the subject of the formula. But I must make y the subject of the formula. Not so.
So she said the school's ordering it.
Ordering. Okay, then I must put my numbers in. Don't worry, I'll send it later. Okay. So we're going to divide throughout by x, not so. So y is equal to the root of 3 over x minus 4x squared plus 1 over x squared. You all agree with that? So is it in that form of a x to the exponent n? No. So you get it in that form. So y is equal to the root of 3x minus 1. I brought the x up. Minus 4x squared, no issue there. Bring x squared up, becomes x to the minus 2. Now can I apply the derivative? Yes. So it's dy over dx equals negative root 3 x minus 2. Remember again, I'm multiplying the exponent by the coefficient and then I minus 1. Multiplying the coefficient with the exponent minus 1. Same story. Okay? So it's going to be 2 times negative 4 is negative 8x to the 1 minus 2x to the minus 3. Okay, you all agree with that? And the question says you must write it with positive exponents. Not so. So the third term and that the x has to go to the denominator, so it's negative root 3 over x squared minus 8x minus 2 over x cubed. Okay. Is something wrong? Okay, any confusion here, people? Okay. Number 19. Number 19, f of x is equal to square root of x minus 3 to root x plus 3. Okay. So that will be f of x equals, get rid of the brackets. So root 3 times, and root x times 2 root x is going to give you 2x. Root x times 3 will be positive 3 root x. Negative 3 times 2x is negative 6x, which gives you negative 3x. Minus 9. You all agree with that? It is root, that's right, it's 3, 9. So what do I do now? Sorry, there must be a root, no? Okay. So before I can apply my derivative, I must show that term out first. So f of x equals 2x minus 3x to the half minus 9. Now apply my derivative. So f prime x equals, that will give us 2. Negative 3 times half is negative 3 over 2x. Minus 1 on that, it gives you minus half. And the derivative of a constant is 0. Since that exponent is negative, so it's 2 minus 3 over 2x to the half. Or this term can be written as 2 minus 3 over 2 root x. Okay. Any issues there, people? No? See, I'm spending a lot of time on here. Okay? You must get the sum right, people. G of x is now number 21. G of x equals 3x squared minus 4x minus 7 over x plus 1. Of course, we can't apply the derivative as it stands. So what do? We factorize the numerator. Definitely x plus 1 is going to be a factor because it will cancel out in the next step. So you've got 3x minus 7. So we check. That's going to give you 3x minus 7 is minus 4. That's in order. So that cancels. So I'm left with 3x minus 7. That is your g of x. But what's the question? G dash x, g prime of x will be 3. Okay. Next one. Number 23. So f of t equals t cubed minus 3t squared minus 1 over t. Can I apply the derivative there? No. Very important at this point, I don't apply the derivative on the first two and change the next one. No. You apply the derivative at the same time throughout the expression. You guys understand? Okay. So this gives us f prime x. No, we must first change the last term. We must bring the t up. So it's going to become f of t equals t cubed minus 3t squared minus t to the minus 1. Can I apply my derivative now? Yes. So f prime of t equals 3t squared minus 6t minus 1 times negative 1 is positive 1t to the minus 2. Since this is a negative exponent, I'm going to bring that down. So f prime of t equals 3t squared minus 6t plus 1 over t squared. Okay. Any issues here? Any problems? So you got all the sums right. Wow. One day we're going to be all like you. I already made 2 mistakes. You guys are better than me, no? Right. F of x equals the root of x minus 2x. 2x minus 3 over root x. Right. Can we apply the derivative as it stands there? No. With our information we can't. It can actually be done. No? But when you go to university, you get the chain rule and the power rule and the quotient rule and all of those things. Product rule. Okay. So we need to get rid of the brackets first. So that's going to give us 2x root x. Root x times negative 3 over x, it will give you negative 3. 2x times negative 2x is negative 4x squared. Negative 2x times negative 3 over x is going to be positive 6x over root x. Or I could have written it as 6 root x. Okay? Yes? Which way? Yeah? So that will give us 2x. Remember that's x to the half. So that will be 1 plus a half is 3 over 2. We must now first get it in this form. It's negative 3 minus 4x squared plus. Now this x to the half. So it will be 6x. 1 minus half is half. Can I apply my derivative now? Yes. So f prime of x is equal to 2 times 3 over 2 is 3x, minus 1 is going to give you half. The derivative of constant is 0. Negative 4 times 2 is negative 8x, minus 1 is x. Plus 6 times half is 3x, minus 1 is negative half. Okay. It will be the minus half. This now gives us 3x to the half minus 8x plus 3 over x to the half. Where that could have also be written as 3 the root of x minus 8x plus 3 over the root of x. Okay, so she asked me to do so you show you. Okay, no problem. Any issues here? You all okay with this? Okay, I'm again talking to myself. Nice. And yeah, I thought after that the test you wrote things will change. But we're still where we are, where we were. So d of x give me x squared minus 9, x squared minus 3x plus 9, x minus 3 to the negative 1. Okay. So if you're looking at d of x here, I can't apply it as it is here. We know that this one here is going to go to the denominator. The x minus 3 to the 1. Not so. However, this here we can apply difference of two squares. So it will become x plus 3, x minus 3 into x squared minus 3x plus 9. This trinomial can't factorize. Okay? X minus 3 cancels x minus 3. Which now leaves me with x plus 3 into x squared minus 3x plus 9. Okay? So what do we do now? Get rid of the brackets. Why? So we want it in that form. So d of x. Can I put the equal sign here? No? That's going to give us x cubed. You should note that this is actually a sum of cubes here. Can you see that? But if you multiply it out, you're going to get negative 3x squared plus 3x squared cancel. Your 9x minus 9x cancel. And positive 27. Okay. The derivative. Okay, here mustn't be an equal sign. We're going to find out Monday why. But the derivative here would give us 3x squared, and that falls away. Okay. Any confusion here? No? For homework, you're going to do for me exercise 6, the even numbers. Okay? You do exercise 6, all the even numbers. For homework for Monday. Friday. I was going to give it to you for Monday, but somebody said rather give it for Friday. There's school on Friday now, no? Because of that person now, that's it. There's work. Yeah, and we could carry on with normal work on Friday. Please don't stay absent. We're going to miss you when you're gone. Alright. Right, so we're going to look at important rules. These are the examples on page, example 1, on page, what page is this on? 155. Page 155. Okay. It's an important rule that I want you to take note of here in this exercise. There's a few of them. Normally I don't do this, but okay, let's do it with you guys. So, here we are told in the first important rule is that the derivative of x, which is f of x plus or minus g of x. So, two functions are either the sum of is taken or the difference is taken, is equal to the individual derivatives. If you take the derivative of f of x plus or minus the derivative of g of x. So here we're going to, in this example, we actually proved it, okay. So here we are told if f of x is equal to x cubed plus 2x and g of x is equal to negative 2x minus 5. You must show that the derivative of x of the sum of the two is equal to the sum of its individual derivatives. Okay, that's basically what we need to prove here. So since this is a proof that of a show that question, what does that mean? We can't go and say straight it's equal. Not so. This is then an identity to us. You guys understand? It's an identity. So you can't take things over the equal sign and all of those things. Okay. Yeah, in this case you're going to prove that the left hand side is equal to the right hand side. Okay, are you all okay with that? So you're taking that into account. What are we going to say? This is now, of course, the left hand side of the equal sign. So it's the derivative with respect to x of. What is f of x? X cubed plus 2x. Plus, because we're adding, plus negative 2x squared minus 5. You all agree with that? Now simplify that and you apply a derivative. Alright, so that gives us the derivative with respect to x. This gives us x cubed minus 2x squared plus 2x minus 5. Is that correct? Apply my derivative, what do I get? You're going to get 3x squared minus 4x plus. You all agree with that? Now let's look at the right hand side. The right hand side, here you're going to take the derivative of every expression there. Not so. So it's d of dx, the derivative with respect to x, of f of x, which is x cubed, plus 2x, plus d of dx, which is minus 2x minus 5. Okay, so let's apply the derivative. What do we get? 3x squared plus 2 plus, that will now give us minus 2 squared here, short in the square. So it's going to be minus 4x, and the derivative of constant falls away. Not so. So is the right hand side equal to the left hand side? So therefore is equal to the left hand side. Any confusion, people? Is there any confusion? No. Okay. Let's look at work example 2. The subtraction one. You guys are studying for your upcoming exam, no? Your maths test. Don't forget, it's only in 2 hours, no? For 100 marks. And I don't know if for those of you who opened the group by mistake, no? Some reason or other this morning, early this morning. You see what time I'm working still on your papers? So it's on page 156. So I gave you your breakdown now, okay? This is example 2 on page 156. Right. So write that rule down. You say d of dx equals, the difference of the two is equal to the derivative of the difference. Okay. They're just showing you that it's the same. Okay. So looking at work example 2. So again, we must show that the left hand side is equal to the right hand side. Not so? It's an identity. So this is on the left hand side of the equal sign. So you say LHS equals derivative with respect to x of f of x, 5x cubed minus 2, minus g of x, which is 2x squared plus x. That's simply going to give us d of dx. That's going to give you 5x cubed minus 2x squared minus x plus minus 2. Apply the derivative, what do we get? 15x squared, carry on, minus 4x, minus 1, and the derivative falls over. The right hand side. The right hand side is simply the derivative of f of x, the derivative with respect to x, is going to give you 5x cubed minus 2, minus the derivative of g of x, which is 2x squared plus x. So the derivative of 5x cubed is going to give you 15x squared, the derivative of constant falls away. Minus, more than one term follows a negative sign, put in the bracket. Derivative of 2x squared is going to give you 4x. Derivative of x is 1. Get rid of the bracket. So it's going to give you 15x squared minus 4x minus 1. Is that the same? It's equal to the left hand. Okay. Let's see what is left. Okay, for homework, I would like you guys to go through the example 3. Just put it on the board here. In example 3, you look here. They give you the rule. Come inside. So this is the rule I wanted you to take note of. The derivative, you see this case is a constant here. Okay, constant times the function is equal to your k times your derivative of the function. Your constant times the function. So here, if the function is x cubed plus 2x, you must show that the left hand side is equal to the right hand side. So here we put the k in front. Okay? So we first multiply the k in, and then we apply the derivative. Okay? Which is 3k squared plus 2k. In the other case, we first apply the derivative, and then we multiply the k in by the constant. And what do you see? The same answer. You guys understand? So because of that, that rule stands. Okay? And the last one, the work example 4. Another bell rang, so I don't want to keep you much longer. You guys got better things to do? No? Yes? Yeah, I know. I know of you guys already. You type. You type, yeah. You don't want to work extra on your maths and, you know, all of these things. But we all want a good maths mark. No? It's like everybody wants to be thin. I also want to be thin. But I don't have time to exercise. So, no results. Yeah, same. Everyone wants the A in maths, but nobody have the time or don't want to, you know, spend the time. But anyway, sad story for another day. Right, the derivative of d of x, you see the product of the two ratios and functions, it will never be equal to the product of the individual derivatives. Okay? And here it was proven. Here you must show that the left hand side is not equal to the right hand side. So when you go with the left hand side, you multiply the functions first and then apply the derivative. I get negative 10x4 plus 12x cubed plus 12x squared minus 12x. Then for the right hand side, you must take the individual derivatives first and then multiply. You take the derivatives, then multiply. We never got what we have on the left hand side. Can you see that, people? So that is not the case. So the left hand side is not equal to the right hand side in this case. Since tomorrow is holiday, I needed to have completed that. So for homework, I would like you guys to do exercise 7. And this is on page 157. Exercise 7 on page 157. On Friday, we're going to start curve sketching, I think the next part is, okay? The cubic functions. Drawing the cubic graphs, okay? Sorry? Don't you want to do everything? For those of you who want to do everything, you can do everything. Otherwise, you can do number 1 and 2. Okay? But if for some reason some of you are going to do everything, I'll answer whatever the issues are. Okay? People enjoy the day off and the rest of your day. Good morning, class. Sorry for keeping you, okay? 1, 4. Two, three, four. Monday. We support the tuck shop. The tuck shop isn't open.
It's not for me, it's for someone else.
Oh. But I'm not going to sell during break also because the tuck shop is. Hey, morning. Morning.